What is the maximum width of slit delta max at which the fringes on the screen will be still observed sufficiently sharp? So let's discuss what is the case when the slit is like a point object. So in that case, central maxima is formed here. So when you take this ray and pass it through the center of the lens, so if you extend that to the screen, that's where central maxima is formed. And let's say it is formed at an angle alpha, so that means this angle is also alpha. Now when the slit is a bit larger, so let's say it is of the height delta. So because of this bottom, let's say the tail end of this slit, the maxima will form here at the original location. And because it is extended now to a height delta, the head end will cause a central maxima here. So let's say this angle is d alpha. So central maxima also shifts by an angle d alpha. So be very careful here that these are not two separate maxima. It is actually a continuous maxima because these are not two separate slits. So it is just initially it was one slit, a single point slit, but in reality the slit is a bit longer. So because of that length of the slit, this maxima spreads out. So let's write that when instead of a point source, slit becomes delta long, the central maxima spreads out. Now let's find the value of alpha. So from 1, tan alpha is equal to h upon f. And from 2, tan of alpha plus d alpha, so that is equivalent of alpha plus d alpha, is equal to delta plus h upon f. So from here, when we cancel out alpha and h by f, we get d alpha is equal to delta by f. Now just like the previous problem, if we want to see the interference pattern with sufficient contrast, then this maxima, which is extended up to here, that should not coincide with the minima. So the minima of this blue maxima will be somewhere here. So there this central maxima of yellow should not reach. So basically the shift in central maxima should be less than half the fringe width. So that's what we'll write here. In order to see sufficient contrast, central maxima of head, that is this yellow part, should not spread out till minima of tail, that is minima of this blue part. So you should be able to see some darkness before you see again an extended maxima, which means BD alpha, so that is the width of this spread out maxima. So because this is B, this is D alpha, so this is BD alpha. So BD alpha should be less than half the fringe width, beta by 2. And we have seen in the A part that beta is lambda f by A, and d alpha we have seen is delta by f. So this gives lambda max is equal to lambda f square by 2ab. Put the values and get your answer. So this is the maximum height, you can say, or the maximum, basically the length of this slit, such that you still will be able to see some contrast. Or in other words, the pattern will be sufficiently sharp.